All right, we're continuing with our systems of linear equations. And now we're going to take it one step further. So there's three approaches to do this. One of them is you graph them, see where they hit. The second approach is called substitution. And so we're looking to see where these lines intersect each other, if at all. Sometimes they don't. And we're going to learn what I think is the most popular of the approaches. And again, it's called substitution. Now here's the idea. We could solve either of these equations for an easy variable. You see, you could have chosen y, and you'd make this negative 2x plus 7. That's easy. Now, or we could have chosen x. That would have been easy as well. Now, we've gone with y here. So we're saying that in this universe, this is what y equals. Okay, well, if that's what y equals, that is equally as true as it's of saying y. We're going to take y out of it and replace it with what it's equal to. So we're going to take all of that, they wrote it the other way around, and we're going to drop it in wherever there was a y. Now make sure you see this needs parentheses here, okay? We need to drop this in parentheses. Now, we've eliminated one of the y's. It's gone. All we have to do now is solve for x with some basic algebra. Send all that through, we get x is 4. Okay, now we have x is 4. We can now put it into either of the two equations. It will work. We have a real number for x. Put that in, crunch it down, and we get y is negative 1. Okay, well, we found it. That is the point. 4, negative 1 is the point and where they intersect. All right, now it doesn't have to be y. We could solve either one. So I'm going to choose to solve the bottom one. Okay, so I'm going to say x is negative 3y plus 9 because that was easy to solve. Now if this is x, let's put it into that top one. I've subbed it in. Now we've only got one I don't know, so we can solve this. Now I'm going to distribute a negative 2. He owns that sign. Now I'm just doing basic algebra. I hope you're following me. Adding 18 here to both sides. So I'm adding 18, so y is 1. Okay, if y is 1, we can use either equation. It doesn't matter. So I've got x plus 3 times 1 equals 9. X is 6. All right. So the point where they intersect is 6, 1. Oh, let's try another one by substitution, or how about this? Let's let them do it for us. Now if we solve this for y, we're solving this for y. Now you'd have to divide or send the negative 6x over, change the sign. Oh, hold on, they solved this one for y. So they're solving this one for y. Dividing across by 2 is how we created this. Now if this is y, wherever there was a y, we're going to sub it in. Now we have just one equation, or with one I don't know. Tidy that up, we get 5/4. Now put it into either equation, and they've chosen this one because they saw that the 4's would cancel. Tidy that up, and you get your solution. Now you can solve for anything you want, but I'm always looking for the easiest one. And I look at that top one here. Now if that's x, let's put that into the other equation. Okay, now the 3 is going to own that minus. I'm going to send it through negative 12y plus 12 plus 4y equals 0. So see what I'm doing here. Negative 12y minus 4. Okay, so I've got negative 16y plus 12 equals 0. Negative 16y equals negative 12. Okay, I divided this by negative 16. That's why my negatives disappeared. Now both of these are divisible by 4, so I can turn this into 3/4. Now, back into either equation I want. Let's go ahead, you could even use this one if you want, but I'll use it up here. I've got x minus 4 times 3/4 equals negative 4. Those will cancel. And you see I'm left with x minus 3 is negative 4. X would be negative 1. So I have it. The point -1 3/4 is the solution to this system of equations. All right, let's try another one here, or pause it and try it on your own if you'd like. I think the easiest thing to solve is going to be this top one, so I'm going to do this. Now, if that's what y is, let's put it in. I'm subbing this into the other equation. I'm going fast with this. I hope you're comfortable. I'm dividing both sides by -10. That reduces, so I had -5/10. That reduces to this. Okay, that's what x is. Now let's find y. I'm going to use the top equation. I could use either one. Okay, now this cancels down. I'm going to get -2 minus y equals 0. I'm going to do this in a little tricky way. Do you see I could just send that over? Y is going to be -2. There's my solution. Okay, now you're going to see this in the next video, but I need to warn you just in case. Sometimes when you substitute in, all the x's and y's might fall out of the equation. And suppose you're left with something like this, 4 equals 5. So all the x's and y's are gone, and you have something that doesn't tell the truth. That is a lie. 4 does not equal 5. Well, that means there's no solution. What must be happening is that you have parallel lines and they never touch, so there is no way to find a place they touch. Or you'll have the x's and y's fall out and you're left with something like this, 0 equals 0. Well, that is true, and it's always true. So it would be infinite solutions. You must be looking at a situation where the two lines are right on top of each other. Okay, so watch out for these two peculiarities. I thought there'd be more slides on that, but I know it's in the next one in a little bit at least. So if everything drops out and you're left with a lie, that's no solution. If everything drops out and you're telling the truth, that's infinite solutions. This is infinite solutions, two lines on top of each other, no solutions, it's parallel.